All right, welcome to another deep dive. Today we're tackling some core Java OOP concepts. We've got a YouTube transcript from the SDT QA channel, session 15, Java OPS concepts.
That's the one, yeah. Method overriding, final, and super keywords in Java 2024 new series, to be exact.
Right. Sounds like a mouthful, but really it's about getting a grip on some of the fundamentals that underpin how we work with objects in Java. We'll be focusing on method overriding and overloading.
And those essential keywords, final and super.
Exactly. So our mission today is to distill this transcript, clarify the relationships between these concepts, and make sure you walk away with a solid grasp of how to use them effectively.
That's the goal. I think it's easy to get lost in the jargon, but these are tools that can really shape how you think about and design your code. So let's dive right in. Method overriding, where should we start with that?
Well, let's try to break it down. So imagine you have a parent class.
Right, like a blueprint.
Exactly, a blueprint. And this parent class has a certain method, a way of doing something. Now, a child class inherits from this parent, right?
Inherits, meaning it gets all the goodies from the parent, including that method.
Yep. But sometimes the child class might want to do things a little differently. It wants to keep the same basic idea of the method, but customize the implementation to suit its own needs.
That's where method overriding comes in. The child class essentially says, hey, I want to use this method for my parent, but I'm going to tweak it to work my way.
So same method name, same parameters, same return type.
But different code inside the method body.
Precisely. You're essentially redefining how that method behaves specifically for the child class. Now, a question that might pop up is, why bother overriding? Why not just create a brand new method in the child class if you want to do something different?
Good point. It all boils down to maintaining a consistent interface and leveraging the power of polymorphism. Let me explain. Think of it from the perspective of other parts of your code that might be interacting with objects. You might be expecting to work with objects based on the parent class's method.
Right, they might not even know about the specific child classes.
Exactly. So by overriding, you make sure that when those methods are called on a child class object, the behavior is tailored to that child class, even though the calling code is written against the more general parent class.
So it's kind of like having a standardized plug that works with different appliances.
That's a great analogy. It's about providing specialized behavior while still adhering to a common contract defined by the parent class.
Okay, so overriding is about specialization while maintaining compatibility. Now, when we actually get down to overriding a method, are there any hard and fast rules? Anything we absolutely cannot change?
The method's signature. That's sacred ground. It must be an exact match between the parent and the child's methods.
Okay, so same method name, same parameters, same return type, all that stuff.
Exactly. If you change any of those, you're not overriding. You might be venturing into the realm of overloading, which we'll get to later.
Got it. So the only freedom we have is in the actual implementation, the code within the method itself.
Precisely. You're free to modify the internal logic, the steps involved in carrying out the method's task. It's like having a recipe. The ingredients in the final dish need to be the same, but you can tweak the cooking process.
That makes sense. Can we maybe solidify this with a concrete example, something a bit more tangible?
Absolutely. Let's say we have a shape class, a basic blueprint for any geometric shape. And this shape class has a method called calculateArea.
Makes sense. Every shape has an area.
Right. Now, we could have subclasses like rectangle and circle, both inheriting from shape.
Okay, so both rectangle and circle inherit that calculateArea method.
They do, but the way you calculate the area of a rectangle is different from how you calculate the area of a circle.
Of course, one uses length and width, the other uses pi and radius.
Exactly. So rectangle and circle would override the calculateArea method, each providing its own specific implementation based on its unique properties.
Right, so when you call calculateArea on a rectangle object, it'll use the rectangle's formula, and when you call it on a circle object, it'll use the circle's formula.
Precisely. And even though the underlying calculations are different, the method signature calculateArea, with no parameters and returning a numerical value, stays the same.
So the beauty of this is that if you have some code that's working with generic shape objects, it can still call calculateArea without needing to know the exact type of shape it's dealing with.
Exactly. And that's the essence of polymorphism. Different objects responding to the same method call in their own specific way.
Okay, overriding is starting to click. Now let's switch gears a bit and talk about method overloading. You mentioned this earlier as something that's often confused with overriding. What's the deal with that?
Method overloading is another facet of polymorphism. It's about having multiple methods within the same class or inherited from a parent class that share the same name but differ in their parameters.
Okay, same name, different parameters.
Mhm.
So it's like having multiple tools with the same name but different functions. You pick the right tool based on the task at hand.
That's a good way to think about it. The key is that the compiler can tell which version of the method to call based on the arguments you provide. So you might have a method called add that takes two integers as parameters and another add method that takes two doubles.
Right, so depending on whether you pass in integers or doubles, the compiler will know which add method to use. Now, how do we keep overriding and overloading straight in our heads? They both seem to involve some kind of variation on methods.
True, but the fundamental difference lies in their purpose and how they're achieved. Overriding is about replacing a parent class's implementation in a subclass.
Mm.
Same method signature, different internal logic. It's tied to inheritance.
So inheritance is the key word there.
Exactly. Whereas overloading is about offering multiple ways to call a method within a class. Same name, different parameters. It's all about flexibility and convenience.
Okay, so overriding is about specialization through inheritance, and overloading is about offering multiple options within a class.
Got it.
Can we maybe see an example of both overriding and overloading in action side by side?
Sure, let's go back to those classes that we were using before. Remember ABC and XYZ. Say ABC has a method M1 that takes one integer as a parameter and another method M2 that also takes one integer. Now, XYZ extends ABC. If XYZ overrides M1, it'll have a method with the exact same signature, one integer parameter, but with a different implementation. Maybe it squares the input integer.
Okay, that's the overriding part.
Now for overloading.
Hmm.
XYZ could have a new method also called M2, but this time it takes two integer parameters instead of one. This new M2 might add the two integers together.
Okay, so we have two versions of M2 and XYZ, the original one inherited from ABC, and this new one that takes two integers.
Exactly. And XYZ could even choose to override the original M2 inherited from ABC with its own unique implementation. So now it has three M2 methods, the inherited one, which can override, and the new one that takes two integers, which is an overload.
Ah, I see. So overriding is replacing an existing method, and overloading is adding new variation of a method. The key takeaway here is that overriding replaces the parent's implementation in the child, while overloading provides multiple ways to call a method.
Got it. Now on to the final keyword. It seems to have its fingers in a few different pies in Java. Where does it come into play?
Final is all about immutability and control. It tells Java, hey, this thing, whether it's a variable, a method, or even an entire class, should not be changed once it's set.
So it's like putting a lock on something. Once it's declared final, it stays that way.
Exactly. Now let's break down how final works in each of those contexts. When you declare a variable as final, it means you cannot change its value after initialization.
Makes sense. So it becomes a constant.
Got it. Think of something like final int max attempts s equals 3. You're declaring a constant that represents the maximum number of login attempts allowed. Trying to change the value of max attempts later in your code will just lead to an error.
Right, because it's locked in. Now, when it comes to methods, final plays a different role. A final method cannot be overridden by any subclass.
So it's like saying, this method is perfect as it is, don't mess with it.
Exactly. It ensures that the method's implementation remains consistent across all subclasses. This can be useful for methods that are crucial to the class's core functionality and shouldn't be tampered with.
Okay, I see how that can be useful for maintaining control over critical behaviors. And what happens when you mark an entire class as final?
A final class cannot be subclassed. It's the ultimate no inheritance sign.
So it's like saying, this class is complete, it doesn't need any descendants.
Exactly. It's often used for classes that represent fundamental concepts or for security reasons.
Right, I can see how that would be useful in those scenarios. So to summarize, final gives us a way to enforce immutability and control at different levels. Variable values, method implementations, and even class inheritance.
It's a good summary.
Okay, we've covered overriding, overloading, and final. The last piece of the puzzle is the super keyword. What does that bring to the table?
The super keyword is all about communication between a child class and its parent class. It allows a subclass to directly access members, both variables and methods of its immediate parent.
Okay, so it's like a direct line to the parent stuff. Why would we need that?
Well, there are a couple of common scenarios where super comes in handy. Imagine you have a variable in your parent class, and you decide to create a variable with the same name in your child class.
Right, that could lead to some confusion.
It could. Using the variable name directly in the child class will refer to the child's version of the variable. To access the parent's version in this case, you'd use super.variablename.
So it's like saying, hey, I want the version from my parent, not my own.
Exactly. Another common use case is with overridden methods. Inside the child's overridden method, you might want to call the parent's version of that same method. In this case, you would use super.methodName.
Right, so you can reuse the parent's logic and then maybe add some additional behavior specific to the child class.
Precisely. It's a way to build upon the parent's functionality without having to rewrite everything from scratch.
Okay, so super gives us a way to tap into the parent's members when needed. Any important caveats to keep in mind?
Yes, two key points. First, super only refers to the immediate parent class. If you have multiple levels of inheritance, super in a grandchild class will only access its direct parent, not the grandparent or any ancestor further up the chain.
Right, so it's a one-step up connection.
Second, super is specifically for accessing members of classes, not interfaces. Interfaces have their own mechanisms for interaction.
Got it. Immediate parent only, and for classes, not interfaces.
Precisely.
Well, it seems we've covered a lot of ground today. We've explored the nuances of method overriding and overloading, understood the implications of the final keyword, and learned how to use the super keyword effectively.
It's been a deep dive into the core principles of object-oriented programming in Java.
So for you, the learner, the challenge now is to take these concepts and start applying them in your own code.
Exactly. Think about how overriding can help you specialize behavior in your subclasses, how overloading can make your code more flexible and user-friendly, and when using final might be the right design choice.
And don't forget about super as a tool for accessing your parent class members when needed.
Mastering these concepts is key to creating well-structured, maintainable, and robust Java applications.
Now, here's a thought-provoking question to leave you with. How does the proper use of these concepts, these tools we've discussed, actually translate into the creation of better software? What are the long-term benefits of using them wisely? And what are some potential pitfalls to be aware of if they're misunderstood or misused? That's something to ponder as you continue your Java OOP journey.
Indeed.
And on that note, we'll wrap up this deep dive. Thanks for joining us.
Until next time.